Very good morning to all of you. Myself, K. Srikanth, Associate Professor working in ECS department at G. Pullareddy Engineering College, Kurnool. Today's topic, Java's magic, the byte code. So let us start what exactly the byte code and how the magic is done in Java language because of byte code. So generally, the programming languages that we are learning today is of high-level programming languages like C, C++, Java, Python. So where the computer understands only binary language, right? There is a requirement to convert the high-level programming language into binary language. For that, we need converters or translators like compilers and interpreters. In Java language, the source code which is written in Java, generally it is saved as .java and it gets compiled by using a exe file called javac.exe, which is converted into byte code, the compiled code using the Java compiler. This is the first step while executing the Java programs. So after converting the byte code, the .java file to .class file, then it is diverted to, the byte code is given to the interpreter. So the interpreter, it reads line by line that is there in the byte code and it converts it into mission language, or we call it as binary form, that will gets executed using java.exe program. So overall, the Java source file is converted into byte code and the byte code is converted into mission code. With the byte, because of byte code, the Java language, it becomes platform independent. And we come across, so to happen this, so we need a lot of components, right? One is, if you see JDK, which is Java Development Kit, and we have Java Runtime Environment, that is JRE, to develop and execute Java-based applications and programs. Let us see a small diagram how the Java programs gets executed internally. So we have totally so 4 components. So one is the JDK, which is the Java Development Kit. The Java Development Kit. So which consists of 2 components. One is development tools, the other one is Java Runtime Environment. If you see the development tools, it consists of 2 important executable files. One is the Java compiler, which is javac.exe. The other one is the Java launcher, which is java.exe. So javac.exe is used to compile .java programs to get byte code, and the byte code is given to Java launcher to convert it to as mission code, that is the binary form of the language, high level language. So which is then diverted to a component called JVM, so which stands for Java Virtual Machine. Java Virtual Machine, which executes the Java applications with the help of Java standard packages and runtime libraries. This is how the Java programs gets executed in real time. So we need a component called Java Development Kit, which takes the help of Java compiler to convert source program into byte code Then the bytecode is given to Java launcher to convert it as binary language or mission language. Then the mission program is given to JVM, which takes the help of Java standard packages and runtime libraries to execute our applications. Hope it is clear what exactly happening in Java language. Let us see one more diagram which gives a clear picture of the execution of Java program. Here you can see a source file called helloworld.java, which is a Java program given to compiler, the Java compiler, javac.exe. It gives an output called Byte Code, which is an intermediate code which makes the language platform independent. Because of Byte Code, the Java is platform independent, and it generates a file called .class file, helloworld.class, which is then diverted to Java virtual machine, where a lot of work has been done within the Java virtual machine. So the first component of Java virtual machine is class loader. So whatever the classes that are part of your program are loaded into RAM, and the classes which are required to execute your program are also loaded into the RAM. Then the other component is bytecode verifier. So whatever the bytecode generated after the compilation, it will be validated. It will check for illegal code. If any illegal code is there, it stops the process and intimates the same to the programmer. If bytecode verification is successful, then the code is diverted to the interpreter. So the interpreter, it executes the code line by line, and the mission code is generated. And there is a comment that Java language is slower compared to our C or C++ language because it uses an interpreter where line by line execution is may happen. Further, the inventor James Gosling has introduced and one more component called JIT compiler, so which stands for just-in-time compiler. Just-in-time compiler, so which compiles the reusable bytecode into machine code, where the performance of Java language has been improved using just-in-time compiler. And there is an environment called runtime environment, which executes the programs and gives the result. Overall execution of the program is well done, and the results are seen in the console with the help of operating system and hardware of the computer. So this is the entire process that is happened within the computer. So where we write .java program that is given to compiler, a bytecode is generated, which is an intermediate code which makes the language platform independent. That is, the bytecode is given to Java virtual machine, where the class loader component loads all the classes that are needed for execution. Then bytecode verification is done. If bytecode verification is successful, then the bytecode is given to interpreter, where line by line execution is done, and it is converted into machine code with the help of JIT compiler, where reusable bytecodes are converted into machine code, and the machine code is given to the runtime environment to execute our applications with the help of operating system and the hardware. And this figure, it gives the overall execution of a C language, where the C language is platform dependent. If you see the C code, which is in the file extension .c, helloworld.c, is given to Windows C compiler, where it generates a file called .exe, helloworld.exe, which is understood by the Windows operating system. Whereas the same helloworld.c is given to Linux C compiler, and it generates a different format of file, that is helloworld.out, which runs on Linux operating system. The same .c file is given to Mac C compiler. It gives a format called .out, which runs on Mac OS. If you see, for every operating system, the extension is different. So that's why the C language is treated as platform dependent. So which is a drawback of the language. So where we need to change the .c file to execute in different platforms. So this drawback is overcome in Java language by introducing byte code. Here in this diagram, it is very clear that the Java code, which is in a file extension called .java, it gives to Windows Java compiler, Linux Java compiler, and Mac Java compiler. All the Java compilers that generate the same code, that is byte code, which we call it as intermediate code. Intermediate code in the format .class, which makes the language platform independent, and the respective OS has to develop their own JVM. So the Linux OS has to develop Linux JVM, Mac OS has to develop Mac JVM to make bytecode to be converted into machine code and run on the system. So because of bytecode, the language, it is platform independent, which makes Java language very popular. So that's why the heading is very clear. The Java's magic is happened because of bytecode, which is an intermediate code that makes the language platform independent, where the .java file can be run on any platform. Maybe it can be run on Windows OS, Linux OS, or Mac OS without any modifications in your source file. Thank you for patience listening. We'll cover next topic in the next video. Have a nice day.